In this first video, I'm going to look at the exam questions and just look at what the solution for each one will do. I'll do them question by question. I noticed on the example exam, there's a numbering issue. The numbers are written over in marker. So I'm starting with problem number 1, which is a directional derivative. So we have some function f of in x and y is equal to x times the exponential of xy squared. And what we want to do is we want to find the directional derivative. So to find the directional derivative, the partial with respect to x is needed. So I'll take the partial with respect to x. And we've got a product rule going on, so I'm going to take the first times the derivative of the second plus the derivative of the first times the second. So we get xy squared e to the xy squared plus exy squared. And that gives me my partial with respect to x. Then I'm going to need the partial with respect to y. And so x is treated as a constant. So what do we have here? We have a little bit of the chain rule going on. So this is going to stay out front. And I get the e as its own derivative. Times the derivative of what's upstairs. So that's 2xy, and so that's 2x squared y. Let me write that in a better order. That's just, right? So we get the partial with respect to y. Here's a constant. So e to the xy comes back down. There's our constant in front. And then n times the derivative of what's here. So that's 2xy. We clean that all up and we get 2x squared e to the xy squared as our partial with respect to fy. And so our gradient of f is the partial with respect to x in the I hat direction. So xy squared e xy squared plus e xy squared I hat plus 2x squared exy squared j hat. And so this is our gradient vector. And let's see what point we were looking for. We want the directional derivative at the point 0, 2. And we want it in the direction of the vector v. Which is 3, 4. I like this because the magnitude of v is it's a 3, 4, 5 triangle, so it's 3/5 in the I hat direction plus 4/5 in the j hat direction. And so our directional derivative then is going to be the dot product of our gradient at the point. So our gradient vector evaluated at 0, 2, dotted with the v vector over the v magnitude. Whoops. What did I do here? Bad notation. Apologize for my notation a little bit. The magnitude is 5. And a unit vector in the direction of v is 3/5 I hat plus 4/5 j hat. And so my gradient evaluated at 0, 2. So I'll put in 0 here, means this first term 0. 0 here means this becomes 1. Right, because the y's won't matter in those multiplications, right? The 0 times all of this is 0. and the 0 upstairs in the exponential leaves that with 1 in the I hat direction. And then in the 0 in the x means this is 0 in the j hat direction. And now I take the dot product of this times this, right? So I'm going to look at the dot product of the gradient and the direction of 0 and 2. Dotted with that unit vector I've created, and so the dot product is 3/5.